Let's finally dive into that Netflix case study, shall we?
Absolutely. This is where things get really fascinating.
Right.
Netflix is a masterclass in leveraging big data to create a personalized user experience.
Yeah.
They have millions of subscribers with diverse tastes, and they manage to keep them engaged and coming back for more.
Yeah, I have to admit, sometimes I feel like Netflix knows me better than I know myself.
Right.
How do they do it? What is going on?
Personalization is at the heart of their strategy, and it's all powered by data.
Okay.
They use your viewing history, watch duration, likes and dislikes to build a profile of your preferences. Then they employ sophisticated algorithms like collaborative filtering, which looks for patterns across users with similar tastes.
It's like they've created a giant network of viewers connecting people based on what they watch. But it's not just about recommendations, right? They also use data to shape their content library, like what they decide to make.
Exactly. One of the most fascinating aspects of Netflix is how they use data to make content decisions.
Huh?
Stranger Things, for example, wouldn't exist without data analysis. They looked at trends, analyzed audience preferences, and used that information to greenlight a show that resonated with millions worldwide.
Wow, big data isn't just about optimizing what's already there. It's about shaping the future of entertainment. But let's not forget about the technical side. How do they ensure a smooth streaming experience? I mean, buffering is the ultimate mood killer.
Streaming quality. Another area where big data shines. Netflix uses real-time data processing to monitor network conditions and adjust video quality dynamically.
Okay.
They're constantly analyzing your bandwidth, making sure you get the best possible experience, and minimizing those dreaded buffering delays.
So it's like there's this invisible orchestra of data behind the scenes at Netflix, orchestrating everything from recommendations to content decisions to streaming quality.
Yeah.
Pretty amazing.
It is. And the impact of this data-driven approach is undeniable. Over 75% of what people watch on Netflix is driven by their recommendations, and they've consistently produced original content that captures global attention.
Netflix is a perfect example of how big data isn't just some abstract tech concept. It's shaping the entertainment we consume every day. It's making decisions for us.
That's right. And just think, this is just one example. Big data is being used in countless other industries, from healthcare and finance to retail and scientific research. It's truly a revolution that's touching every aspect of our lives.
Well, I'm hooked. This deep dive has already been an eye-opener. We've gone from the basic characteristics of big data to seeing it in action with Netflix. It's clear that this technology is more than just a buzzword. It's a powerful force shaping our world. But we've only just scratched the surface. There's so much more to explore.
Absolutely. And in the next part of our deep dive, we'll roll up our sleeves and get a bit more technical. We'll delve into the nuts and bolts of big data processing, starting with the MapReduce framework.
Sounds good to me. I'm ready to dive deeper into the engine room of big data.
Let's do it.
Welcome back. I'm ready to get into the nitty-gritty of big data processing. Last time we talked about the 5 Vs, Hadoop, even NoSQL databases. It's a lot to take in.
It is.
But I feel like we're building up a good understanding of what big data is and why it matters.
That's great to hear. Now, let's delve into how it actually works.
Right.
Remember that MapReduce framework we talked about? That's where the magic happens when it comes to processing these massive data sets.
Yeah, MapReduce. The production line for data. I'm still a little fuzzy on the details, though. Can we break it down step by step?
Absolutely. Imagine you have a huge data set, way too big for a single computer to handle.
Right.
MapReduce comes in and divides that data into smaller chunks and distributes them across multiple computers, allowing for parallel processing. It's like having an army of workers tackling the problem simultaneously, each working on a small piece of the puzzle.
Okay, so divide and conquer.
Yeah.
But how does that actually work in practice?
It all starts with the input files, which is the raw data you want to process.
Mm-hmm.
This data is usually stored in HDFS, the Hadoop Distributed File System. Remember that foundation of our Hadoop building we talked about?
Yeah, HDFS.
That's HDFS.
Keeping our data safe and sound. But Hadoop needs to know how to read the data, right? It's not like it can just open any file and understand what's inside.
Exactly. That's where the input format comes in.
Input format, okay.
It's like a set of instructions that tells Hadoop how to split the data into smaller pieces called input splits. Think of it like cutting a giant cake into slices.
So input format is like the recipe for slicing up our data cake.
Pretty much.
Okay, makes sense. What happens to those slices? What happens to those slices then?
Each input split is then processed by a separate task, and the more splits you have, the more parallel processing you can do, which speeds things up significantly. That's the beauty of distributed computing.
Okay, so the data is divided into manageable chunks? Then what?
Now the record reader comes into play.
Record reader.
Its job is to read the data from the input splits and convert it into key value pairs.
Key value pairs. Why this specific format? Why not just keep it as raw data?
Great question. Key value pairs make it much easier to sort, group, and aggregate data. Imagine a library where every book has a key, like its title, and a value, which is the book's content.
Yeah.
This system makes it incredibly efficient to find what you're looking for.
So it's like organizing our data library for easy access. Okay, so we've got these key value pairs. What happens next? Where do they go from there?
Now the real processing begins. The mapper takes those key value pairs from the record reader and applies logic or operations to them.
Okay.
This is where the magic happens. You can filter data, transform it, extract important information, all sorts of things. It's like having a chef in our data kitchen who takes those ingredients and starts whipping up something delicious.
The mapper is the data chef. I like it.
Right.
But sometimes chefs need help in the kitchen, right? Like a sous chef to prep the ingredients before they go to the main chef.
You're exactly right. That's where the combiner comes in.
The combiner.
It's like a mini reducer that performs a quick local aggregation of the data before it's sent on to the next step.
Okay.
This helps to reduce the amount of data that needs to be transferred, which can be a big time saver.
So it's all about efficiency. Less data to move around means things run faster and smoother. Smart.
Exactly. Now, if we're using multiple reducers, the data needs to be divided between them. That's where the partitioner comes in.
Okay.
Its job is to take the output from the mapper and assign it to different reducers, ensuring that all keys with the same value end up in the same reducer. Think of it like sorting laundry into different baskets based on color.
Okay, so it's like organizing the data for the next stage of processing, keeping things tidy and efficient.
Yeah.
What happens after that? What's the next step?
Next comes the shuffling and sorting phase. This is where the data gets moved across the network from the mappers to the reducers. It's like shuffling a deck of cards and then sorting them by suit.
Shuffling and sorting a massive deck of data cards. Sounds complicated.
It can be a complex process, but Hadoop is designed to handle these large data transfers efficiently. During shuffling, the data is sorted by key, which is crucial for the next step.
Okay, so the data is all organized and in the right place. What does the reducer do? This is where we finally get to see the finished dish. Wow.
Yeah, you got it. The reducer is the star of the show. It takes those sorted key value pairs from the mappers and performs the final aggregation or processing. This could be summing values, calculating averages, counting occurrences, anything that produces the desired output. It's like taking all those prepped ingredients and turning them into a delicious meal.
The reducer is the master chef, putting it all together.
Yeah.
What happens after the reducer has done its magic? What happens after the reducer has done its magic?
Then the record writer steps in to write the final output from the reducer into output files. These can be stored back in HDFS or anywhere else you need them.
So it's like serving up the final dish and presenting it beautifully on a platter.
Exactly. And just like with a meal, we need to specify the format in which we want the data presented. That's where the output format comes in.
Output format.
It determines how the output data should be written and stored.
MapReduce is like a well-coordinated symphony of data processing, with each component playing its part perfectly. It's pretty amazing how the system can handle such massive amounts of data.
It really is a remarkable framework.
Yeah.
But the big data world is constantly evolving, and new tools and technologies are emerging all the time.
Oh, for sure.
One such technology that's gaining a lot of attention is Apache Spark.
Spark. I've heard that name buzzing around too. How does it fit into the picture?
Spark is often seen as the successor to MapReduce, and for good reason. It's a fast and general-purpose cluster computing system that can handle both batch and real-time data processing. It's like MapReduce on steroids.
Oh, MapReduce on steroids. I'm intrigued. What makes Spark so powerful?
One of Spark's key advantages is its in-memory processing capability. It can store data in memory across a cluster, making it significantly faster than MapReduce, which relies on disk-based storage. Think about it like the difference between accessing information directly from your brain versus having to go look it up in a book every time.
That's a great analogy. Direct access is always faster. So Spark is like having a super fast data brain.
Exactly. And Spark is also more flexible when it comes to programming. Developers can use languages like Scala, Java, Python, and R, making it easier to integrate with existing systems and build complex data processing pipelines.
So it's faster, more flexible, and speaks multiple programming languages. Pretty impressive. What kinds of tasks is Spark really good at?
Spark is particularly well suited for tasks that require iterative processing or real-time analysis. For example, it's a popular choice for machine learning applications, where models need to be trained on massive data sets, constantly refining themselves. It's also great for stream processing, where data needs to be analyzed in real time as it arrives, like monitoring social media trends or tracking website traffic.
So Spark is the go-to technology for cutting-edge, big data applications that need speed, flexibility, and real-time insights.
That's a great way to put it. While MapReduce is still a valuable tool for certain batch processing tasks, Spark is becoming the preferred choice for many big data applications, especially those that demand high performance and agility.
It's amazing how quickly the big data landscape is evolving. It seems like there are always new tools and technologies emerging to keep up with the ever-growing volume of data.
Absolutely. And we've only just begun to explore the vast ecosystem of big data tools.